Hello friends, welcome back to the bench. Today we have this awesome 1724. Normally when these make it to me, there's usually just a battery replacement or a bent heatsink. Obviously the screen, that's usually the lagged BIOS, typical issues, and that's usually what I do on these. But once in a while, some computer makes it to me that doesn't turn on, and this was the case for this one. So let me show you what I usually do and what sometimes happens. This is a curious case, and well, first of all, visual inspection. You can see the heatsink has been not removed. Someone tried to remove it, I guess. I don't know what the deal was with that. The display cable and the digitizer cable. Actually, this is the display cable, this is the digitizer cable. Ripped, right? So the shields weren't touched. Actually, none of the shields were removed. I removed them to do the measurements. I didn't remove these because I didn't need to. But I put on the charger and we have zero current draw, right? Right now there is about 42 milliamps, a little over half a watt that it's consuming. So what I do is this. First we need to know whether the EC is powered, because if the EC doesn't receive its voltage, the computer will not turn on. It's the EC chip that tells the computer to turn on. Okay. Now our EC chip is this one. And we have two voltages that it requires. This is the VCC EC. And this is the main voltage that powers up this chip. The voltage that we want to read over here is roughly 1 volt. 100 millivolts, 0.1 volt. And we have that voltage. But when I turned it on, first thing I checked was this, no voltage, right? So I turned it off. And I checked the resistance on it. Last one that I had that wouldn't turn on, no, not the last one, was shorted EC. All right, we found it with the thermal camera. As you can see, this one is showing 9K here, which is normal. So what is wrong? For this voltage to be present, as I said, there are two of them, and this is 3 volts on this side actually. It's called 3 volts, but there's going to be roughly 300 millivolts on this. And actually, let's check it. Here and the ground. What am I checking for? Oh, wrong side. Yeah, wrong side. 3.3 actually. So yeah, I was wrong. 3.3. Both of this voltage is created by this chip. So this is one of our first voltages, and the voltage that we want to see here is 3.3. Voltage we want to see here is on roughly 15. This is VSys, also called V always on. If we don't, this comes directly from the charger. Almost directly. It goes through oh my god, there's a latch basically. So there is some stuff on the way. So sometimes you will not see 15 volts over here, which means well, the repair should be easy if you don't have 15 volts over here. but we do. And so the next thing is this little fella over here. It doesn't look like much, but this part is that turns it from whatever S state to higher S state. Alright, so this is basically a logic gate, and it receives two voltages, and if both are present, the output is high. When the output is high, just a sec, this one receives 3.3 standby, and from 3.3 standby it receives the on this pin, it receives the on signal from that logic gate, and that enables our EC voltage, which is EC voltage is on this resistor, and SSD voltage is on this resistor. So this also supplies our SSD. For all those to be present, we need to have 3.3 standby, which is controlled by this chip, and this is the coil that produces it. So again, right here we have 3.3. So this is fine. The computer should turn on, even though it's still not charging. But based on what the battery looks like, I would be surprised if it did want to, charge. So now let's just quickly remove the two shields and connect the screen, turn it on, and see what it does. The SSD is not present, so we're not going to find out where this computer is from, but that's fine. Alright, and the digitizer is working. There is no password on the BIOS. This is 256 machine. So let's see if the battery, well, I'm sure battery won't hold any charge. That's not surprising, but it's working. So now the question is, what was wrong with it? Why did it not want to start charging right away, or why did it not turn on? It's a good question, very good question. Oh, I forgot to put the heatsink on the CPU, but luckily there's no SSD, so we didn't go into Windows, because that could have overheated the CPU. There's some damage over here. Obviously the shields were damaged too, but they were not removed. I wonder why this screw was removed. Perhaps someone thought that this screw held the SSD, possible. But also, there was screw removed from over here. This is the screw that holds the fan. Why was this screw removed? Hard to say, but it appears that at least someone tried to remove the heatsink and just kind of gave up. Because this screw over here was also wrong. This is not, the screw that was over here was not the screw intended for this hole. Luckily it was roughly the same size, so we have no damage. You can see that on the back. If you put the long screw, there is a little bump where the screw is if you put the long screw, but that's about it. You didn't damage the board, that's fine. Perhaps they couldn't take off the CPU heatsink, because yeah, it gets pretty stuck to the board, so you need to kind of when you grab it like this, right, you need to pop it from this side and this side, right? If it doesn't work, then you switch to the other two sides, and you just kind of have to wiggle it until it loosens. If you pull too hard, you're gonna bend the bracket, and the sink, the heat sink will not be sitting right. So what was wrong? I don't know, but this is not the first case that I have. Check this out. We're gonna connect to the ground and the VSys. VSys, or in this case, this is this is VSys, and it's also used for charging the battery. So the voltage, see, there was 12 volts for a second, and now it's 8.6 because it started charging. It didn't start charging, but it emitted 12 volts, then detected the battery, because it's not going to start charging until this transistor opens, right? And this process, for some reason, can be delayed. And I think that this will happen when the battery doesn't work, when the battery is completely dead. There are two little diodes over here. You can't really see them, but over this resistor over there underneath. One is pointing to the left, the other one to the right. These two diodes, one is connected to the battery, the other one connected to the charger. So this resistor will always have the voltage coming from either from the battery or from the charger. In this case, this is charger voltage because it's 15 volts. If it was battery voltage, it will be closer to 12. This voltage is then opened by these two transistors and supplied to this chip, which in turn controls this chip, which controls this coil, which produces voltage, right? And finally, it is opened. It goes through this resistor. Let's see if we have charging 8 volts, and through here, and it's open. It's trying to charge the battery. This point goes directly through these 4 coils. This is basically the battery. So the battery receives 8.6 volts, which is when the battery is fully discharged. When the battery is almost fully charged. Yeah, this would be closer to 12 volts if the battery was completely discharged. So for some reason, our charging circuit detects that the battery is charged. So this could be the issue. Basically, the battery caused this issue, or there's something that I'm missing, the way the circuitry is built, that there can be a significant delay. And I've seen it in another machine, and that was a delay of roughly 30 seconds. When you connect the charger and you measure at this coil, you get 0. And then 30 seconds pass, and the voltage appears, and the computer turns on. This is one of those cases. So what I'm gonna do with this one, obviously there's not much dilemma about it. Replace the battery, because obviously that's that needs to be replaced. Obviously I'm gonna put 256 gigabyte SSD here. I don't see anything wrong with anything. Obviously I will replace the paste. Well, the screen itself, you can see that it has been left here, which means none of the antennas are damaged, so that this is perfect. I like it that way. And that's pretty much it. I'll just replace the shields, install the system, and we're gonna give it a nice little test. If it passes, then the computer is ready, refurbished. The only thing that I need to worry about is this damage here. It's bent. See, because it it suffered the fall here. So I'm pretty sure I can bend it. I should be able to bend it. See, just hit it from over here a few times, then over here, and then on the flat, just hit it over here, and that should make it straight enough for the new screen. If not, I could replace the frame, but with the frame replacement, it's kind of a hassle, because you know, this number over here in the back, that is your windows, right? So if you replace the frame, then you get different windows, which is not a huge issue because you can swap them, as far as I know. But also, if this is 256 and you only have frames for 128s, then you know, whoever looks at it sees it as 128. So if you sell it as 256, someone might feel cheated. So it's like an extra hassle, basically. Alrighty, very short presentation on a 1724 weird issue, but since this is the second time that I'm receiving the computer that behaves this way, I have a suspicion that they just work that way. And it's very easy to just kind of mislabel this as something's wrong. It's not charging, it's not turning on. Put it on the charger and keep it for a few minutes on the charger, and then turn it on again. It might turn on then. Very simple fix. Even without understanding of how it works, this is the fix. Just connect it to the charger, leave it charging. Even if it's not charging, you see that it's not consuming power. Just leave it, and eventually it might turn on. Alrighty, thank you fellas very much for watching, and I shall see you in the next one.